Hey, everybody. Welcome, welcome. Nice to see you all. Come on in. How we doing? Sure. Yeah, if you can join with camera, that is ideal, but if not, that's okay too. I just saw a couple people messaging me about that, so thank you for letting me know. Good. Well, I want to get right to it today. I'm happy to take any upfront questions that you have on the administrative front. I have a couple of quick announcements, concerning those kind of housekeeping matters, but then I really want to get right into the crux of the subject matter. So, number one, due dates. I'm going to make problem set 3 due on Saturday night instead of Friday night. That way you have a weekend day. I know that that's helpful for some of you folks who have work or classes or, frankly, it doesn't need justification. I'm happy to give you another day, a weekend day in particular. One quick second, please. Yes, sir. I'm not sure. Go look around, okay? No. So that's one thing. Yeah, so Saturday by midnight, please have that submitted. I realized just a couple days ago that, or was it yesterday? My days are all running together, that my solutions to problem set 2 were not previously posted. So those are now posted on the website if you want to go back and review problem set 2 solutions. In addition, a couple of other things I want to bring your attention to on the class website. Number one is under the assignments, you will see the data analysis project, which you already had instructions for. And we talked a little bit about that. I also just posted for you an outline, which is meant to give you a sense of the overall organizational structure that I would suggest for your project. Now, there's room for variability in there. It's not set in stone that you need to follow that particular outline. But generally speaking, I think that's a pretty good default organizational structure that will clearly and efficiently take care of the different things you need to take care of in the assignment. And so if we're here, under assignments, you have the original instructions, and then here for outline, if you click that, you'll get just a very basic overview of how you might want to structure the thing. So very quickly, and we're going to see this in Michael Ross in a minute. I'll also dig up, I think, a couple of example projects from previous students, your graduate student SIS600 predecessors, so that way you can see a couple of data analysis projects. I can't provide you a flawless example, an A+ example, just because there's always things that I can, and you could too, if you were scrutinizing them, provide some feedback about to say, oh, you could improve this, or I think you could demonstrate this better, or this graphical representation of your data could be, this. So there's always feedback and critique and places, room for improvement. But all in all, I'll give you a couple of, let's say, good examples. So that way you can see what a couple of kind of better data analysis projects look like. But in short, I'm not going to kind of detail all of this out, but just to kind of quickly show you the outline, we're really talking about asking your question and motivating it a little bit. So, within a couple of paragraphs, if that, you should be able to tell us what your topic is, get directly into what the question is, and motivate it in the sense of telling us why it's a puzzle or why it's an interesting question, or framing it within a broader discussion or debate, right? Do something that essentially kicks off your description of your topic and your research question. After that, you're going to have a section where you state succinctly the relevant literature, and then enter into your own brief discussion of your thesis or your argument. You know, what is the basic theory that you're proposing that you want to test with a hypothesis? Now, I'm going to show you in a second when we go over the Michael Ross reading that I do not want this to be some lengthy literature review. This is like, have 3, 4, 5 different scholarly sources that are relevant to your topic and question to help you put your study in the broader context of other studies on the topic. That helps to motivate it. So you could combine all of this into an introduction like Michael Ross does. So I'll show you that in a second if you wanted this all to be one section. But some folks really like to have an introduction that just is in your language and stands on its own. And then you have a separate section that says, here's some literature on this topic. Here's my theory where I'm trying to put forward a testable argument. And then you generally end that with a hypothesis or a couple of hypotheses that you want to test. From there, you're going to move into what I consider the more important parts of your data analysis project. Because at the end of the day, this is a research methods class, not a class on whatever your topic is. So here is where I really want you to be discerning about making sure that you're very clear and comprehensive in the methodological aspects of your project. So be very clear about the unit of analysis of your data, the scope, right? What is the spatial and temporal coverage of your data? What are the variables that are important for your hypothesis? That would be your independent and dependent variables. And then also a little discussion on each control variable would be important as well. And for those things, you need to efficiently give us all of the main information that you generally would and that we normally read about those different variables. So you can look at any of the empirical studies that we've read this semester, and you will find something along these lines, right? Where when we pick apart these different studies, we've identified in the research design, what is the dependent variable? How is it measured? What is its source? What are the possible values? And sometimes, right, there's a nice table with descriptive statistics of the main variables in the study. The control variables don't necessarily need quite as much detailing, but you still want to have some conversation or some introduction to those different covariates that you're going to include. So after you lay out the data and the methods, you're going to move into your analysis and results section. Now, again, this is where things can vary a little bit. You could incorporate a discussion of your methods up here in this data section, right? And really talk about the methods that you're going to employ here, and then make this analysis and results section purely about your findings. Or, as the way I've set it up here, in the analysis and results section is where you can introduce the method that you used, right? Let's say, oh, I have a categorical independent variable and categorical dependent variable, and therefore I did a cross tabulation and a chi-squared test. Here are my results of that, right? So you could just include that here altogether. Alternatively, though, you could have said in your data and methods section, after you described all your data, you could have said, for the bivariate test, I will conduct a cross tabulation test with a chi-squared test. I'll then move on and do a multivariate analysis using logistic regression. So you could put these things in different sections depending on your preference, okay? And I elaborate on that a little bit further here, where I say this section can vary in terms of how you want to tell your story. about the methods that you're using, right? You could describe each method individually, followed by the results, or you could discuss wholesale the methods that you're going to be using, and then go about doing the analysis and discussing the results. So regardless of your approach, though, this is the place where you need to interpret your findings statistically and substantively. And that's why we practice this every problem set, in the practice problems, in the lectures, and even in our class discussions. The most critical things that you need to do when you're actually conducting the hypothesis tests is to not only obtain accurate and precise results, but to discuss them. And when we discuss them, the two main ways we want to go about doing that is to discuss them statistically in terms of the statistical significance based on p-values, coefficients to standard errors, and how those tell us whether we have statistically significant results. And then the second piece, of course, is to discuss them in substantive terms, right? What is the magnitude of the effect or the relationship that you're observing? In order to do that well, you also want to provide any relevant tables or graphs, plots, graphical representations of your data and findings that you think would help you convey those results to your audience. And then at the very end, you can conclude with a more general discussion about, what we've learned from your study, limitations of the study, paths for future research that you might pursue if you were to take this study further or develop or elaborate on it, what kind of policy relevance it has, that kind of thing. But that's a pretty short, couple of paragraphs maybe at the end just to wrap up. The real bulk of what I'm looking for you to do is here in the data and methods and the analysis and results sections. And some people, just to conclude this, some people have likened this to a process by which you essentially create your own problem set and complete it, but write about it in more of a report format than in a discrete, question by question format like I give you in a problem set. So I don't know if that's helpful, if it clarifies or if it confuses, but I've had some people say, well, essentially our process is to write up a problem set of our own where we have a question, we put forward a hypothesis, right? Think about Colgan from even problem set 1. I said, well, what's one of the main hypotheses that he puts forward? And then the rest of that, those questions that came after were, what are some of the descriptive statistics that describe those variables? Well, maybe not in problem set 1 so much, but then in other problem sets, what would the appropriate bivariate test be? What were your results? Discuss them statistically and substantively, provide a scatter plot or a box plot, right? So you're doing the same kind of thing here in terms of charting out your plan. You're just going to write it up in more of a holistic report. Are there any questions about that? Okay, well, good. Seems like it's pretty straightforward then. Good. Beyond that, there's something else I want to point out to you from the class website that may be useful for you. And this is under handouts. I decided not to use class time for this because it won't be as relevant to folks who already know what data they want to use for their project, or whose project doesn't use country level data. But it will be relevant for those of you who are looking for data or who are using country level data, and you might need some additional indicators or measures of variables that you want to bring into your project. And that's handout 15. And I think it's just, if I remember right, it took me about 15 minutes, maybe 20 to record. But it's essentially about how we can pull World Bank data directly into Stata. And so you don't even have to go and obtain data from the World Bank website and download it as an Excel file and import it into Stata after you clean it up first in Excel and all this kind of stuff. There's a package in Stata called WB Open Data. And that tutorial shows you how to essentially install that package, which you already know how to install packages because we've discussed that with like the stout command and stab, how to install a package into Stata. And so here you would do ssc install WB Open Data, and that would install the World Bank Open Data package on your installation of Stata. And then from there, I just give you a tutorial about how to find the variables that you might want to pull into Stata and then pull them directly into the format that you're used to, right? Country or country year format. So that should help you out if your data set is cross-national or time series cross-national in nature. And I think that's all of the kind of updates I wanted to tell you about. Okay. So with that said, a couple of other things. So here's the the gist of how I want to run class. I'm going to show you well, before we open up Stata, what we're going to do is discuss any questions that you have about problem set 3. I want to front end that. So we can have an open discussion about problem set 3 or any other questions that you have related to practice problems 4 or recent lectures on logistic regression analysis or anything like that. After that, I want to jump right into the Michael Ross reading and talk about what Ross is doing in all of those many different models that he estimates or runs in his paper, and why he's doing that and how that represents different forms of empirical richness. And then after that, we can open up Stata and maybe take a look at a couple of more advanced or a la carte kinds of things around transforming variables and stuff like that. I'm also aware it's really gorgeous outside for those of you in the mid-Atlantic and that kind of thing. And so, if at some point you feel like you've gotten what you need to have gotten out of class, then you can take your leave. And so I'll try to give you a cue for when that is. And if it seems like we've all exhausted our desires to be together this evening, then we can all go a bit early. So with that said, let's open up on problem set 3. Maral, go ahead.
Professor, about the problem set 3, would you mind giving some clarification about question 1, section D? With the...
Can you say it again? Question 1, section what?
Section D. The relationship, okay. The difference between the value and...
Yes, I can. I think I know what you're speaking to. In fact, I had it in my notes that that's one of the things I wanted to discuss, not purely based on problem set 3, but just in general, because it came up in problem set 2, and now it comes up differently in problem set 3. And so let's talk about what we're really talking about is the difference between predicted change and predicted value, right? The difference between predicted change and predicted value. Maybe what I can do is this. Yes, okay. Good. So we have, predicted change, delta, right? And then predicted value. Now, both of these are based on the fact that we can get a regression equation, right? So let's do this with a basic linear regression first. And we know our regression equation is y equals alpha. That's an alpha. Alpha, wow. Alpha plus beta x, right? Does that look like a D? Having trouble writing with this. Anyway, you get it. Alpha plus beta x. So predicted change asks, what is the amount of change we would expect, therefore predict in y for a certain amount of change in x? And so you're used to this based on your problem set 2, where I think the question was, how much change would we expect in troop commitments based on a certain amount of change in refugee inflows? And so we can even, think about our problem in that light, right? It's troops equals, does anybody remember it was like 114, let's just say, I could be wrong, but it was like 114 plus, I think it was something like 0.00093 times refugees, right? A refugee inflow, right? And so in order to get the predicted change, all we have to do, right, predicted change, is multiply the beta coefficient by the change in the independent variable, right? So it's beta coefficient times change in x. And so this is why when you were calculating how much does troop commitments change when refugee inflow increases by 10,000, right? Then it would essentially be 0.00093 times 10,000. Right? Or if we wanted to know what is the predicted change in troops when the refugee inflow variable increases by the interquartile range, right? And we remember, I think, that the interquartile range was 0. If we used our entire sample of data, then it would be times 0, which equals 0, no change, right? And I think this was something like, well, of course we know what it is, 9.32 it was. We're only using one decimal, so 9.3. So that's a troop increase of 9.3. And then the other one was by the standard deviation. So it's 0.00093 times whatever the standard deviation was, which gives you, it was 14.7 troops, right? And then some of you went one step further. Some of you knew why you were doing it. And I think some of you were just doing it based on the process that I had, discussed in the lecture. But what you ultimately do to get from 14.7 troops to convert it into standard deviations is divide by the standard deviation. Because then that will put it in the units of the standard deviation, right? So some of you went ahead and just stuck with troops, right? And then some of you put it into standard deviations of troops. It's like, I think it was something like this, or maybe it was 0.34, but it was something along those lines. Standard deviations. Now, notice very quickly before we move on to predicted value that what we're doing here is either just multiplying, just multiplying the beta coefficient I can't figure out how to, there we go. Just multiplying the beta coefficient by the change in x. That would be the same, and I saw a couple of you do this, that would be the same as if you solved for the equation 2 different times. Right? It's the same as if you solved this equation including the constant term for 2 different numbers. So you could do, right, troops equals 114 plus 0.00093 times, let's just pick a number like 50. And then you solve it again for 10,000 more than 50, right? And the difference between these two, meaning if we subtract one from the other, the difference between them is going to be this change. Because it's the amount of change that we expect to see in the dependent variable for a 10,000 unit increase in the independent variable. And it doesn't matter where we are on the x-axis of refugees, because the slope coefficient is constant. It's the same, no matter where we are, right? So if this is troop commitments and this is refugees, see if I can zoom in, yeah, a bit there. So if this is troops and refugees, and we have, let's just say, here's our line of best fit, and imagine that's a straight line and therefore has a constant slope coefficient, then and let's just use these markers as best we can, right? We know already that the beta coefficient is when we increase by 1, right? So it's like increase from 0 to 1. And our change in y, our change in troops, is how much we have gone up on the y-axis, essentially from here to, it looks like about there, right? How much we have gone up on the y-axis for this much change, right? Going from 0 to 1. And so it started here and we ended here. And so this is the amount of change for a 1 unit increase. Now let's imagine for a second that instead of that being 1, and therefore this is the beta coefficient, right? Let's imagine that that's 1,000. And therefore this is 2,000, this is 3,000, 4,000, 5, 6, 7, 8, 9, 10, right? What we're asking here is, what is the change in the y-axis, right, for our line from 0 to 10,000? Imagine that's straight, right? So from 0 to 10,000, if it starts here and it ends roughly there, well, the amount of change is, this. And so that's going to be beta coefficient times 10,000, right? Because the beta coefficient is the change when you go up by 1, but now we're going up by 10,000. Now here's the key. There's nothing, or it's not a key, but it's a way of thinking about it. It doesn't matter if we actually started at 0 and ended at 10,000, right? We could have started at 1,000, right here, and ended at 10,000 more than that, which would have been 11,000. And the change is still a change of 10,000. Instead of from 0 to 10,000, we're now going from 1,000 to 11,000. And the point is, how much does troops increase when refugees increases by that 10,000? And it's going to be the same no matter what, because the slope coefficient, right, the beta coefficient is the same. It's always the same thing, 0.00093. Whether you're going up by 1 from 0 to 1, or from 372 to 373, or from 5,726 to 5,727, right? No matter where you are on the x-axis, an increase of 1 unit will be an increase of beta coefficient in the dependent variable, which means an increase of 10,000 units will be an increase of beta coefficient times 10,000 in the dependent variable. Or an increase by the standard deviation, whether you start at 0 and end at the standard deviation, or you start at anything else and add to it the standard deviation, right? No matter what, the beta coefficient, the change in troops will be the standard deviation times the beta coefficient, right? And that's just a function of the fact that our model is a straight line. Our model of the relationship between refugees and troops is a straight line, and it doesn't vary in terms of that relationship based on where we are in this on the x-axis. And so we can think about this as, yes, beta coefficient times the change in x, which is the same as saying solve the equation for one value, then solve it for another value that represents the change in x that you're interested in, and then subtract the two to get the difference. Right? Which would be, as we did here, find the value when refugees is 11,000, right? So you could solve the equation. And that's what, that's what it would be here, I should say. I mean, so I didn't do it with the 50s. I did it with these. So let's do solve it at 1,000, then solve it at 10,000, and then subtract this one from this one, and your answer will be the same as simply this multiplication problem. So therefore 9.32. And you can go ahead and do it if you want on a calculator real quick. You'll get the same thing. Questions about that? So that's predicted change. All right, now I can make this really easy. This won't take nearly as long when we talk about predicted value. Okay, predicted value. So this one, this is all, predicted change. This one is predicted value. And for our predicted value, what I mean is solve for x. What is the estimate of troops when refugees is exactly some number? Not when it changes by a certain amount, but when it is a specific value. And so what you would be doing is solving one of these equations, but you're not subtracting it from something else, right? You're not looking for the difference in troop commitments based on some difference in refugee inflows. You're wanting to know the number of troops likely to have been committed based on our model, right? So what's our best estimate of the number of troops committed based on some specific value of refugees? And so there, you would actually solve the equation in its entirety. And that then brings in one additional very critical piece of information that we didn't before, when we just multiplied the beta coefficient by the change in x. The additional piece of information is that we're including now our constant, our starting point, what you know as the y-intercept. What does our model suggest the number of troops will be when refugee inflows is 0? So that's a very important reference point, or an important kind of marker of, quote unquote, the beginning. In other words, when X is 0, what is Y? If we don't include that, right, then we're saying, what is the change we expect in troops for a certain amount of change in X, refugees? But if we do include the constant term, the y-intercept, then we are designating a very specific starting point over here for our line, which then tells us that the model estimates that the number of troops committed when refugee inflows is, pick a number, is the result of solving this equation. And so you can even think about the names for these two things: predicted change versus predicted value. Predicted change is how much do we expect the dependent variable to change when the independent variable changes by some amount. And the beta coefficient is when it changes by 1 unit. And you know you can manipulate that mathematically to see how much it will change based on other amounts of change in X, not just one unit increase. Predicted value, on the other hand, is not how much does the dependent variable change for a certain change in X, but what do we expect it to be for a certain value of X? And for that, we simply solve the equation for that value of X. Does that make sense? You follow? Any questions about that? So in problem set 2, I asked you about predicted change. In problem set 3, I'm asking you, at least for that question that prompted this, Maral, I'm asking you for predicted value. Okay, very good. Any other questions on problem set 3? Yeah, Maren?
I just have a quick question based on rounding based on different units of measurement. So like in different models, some of the variables are deaths from floods or refugees, inflow. And when we're kind of writing out our analysis and say like there's a predicted value of like just a made up number, 100.62. Since we're talking about variables that kind of in the real world only make sense in integers, would you like us in our analysis to round up to a whole integer?
No. Go ahead and include decimal places. Generally speaking, you can go with like a couple of decimal places if you have whole numbers before the decimal place. If there is no whole number before that, it's like 0 point something, then often we will want more than 2 decimal places. That has to do with something called, critical numbers, and it's, tangential. It's related, but it's tangential to the class, and it's not worth kind of more time. So I think the rule of thumb is just include a couple of decimal places. Part of the reason why that is because if we're thinking about orders of magnitude, especially with things, like refugees or things that we end up counting, perhaps later or have values for in our data in much, much higher numbers, then rounding can very quickly lead to consequential differences in results. If you round a 3.57 to 4, but then you ultimately do a substantive effect or kind of marginal effect calculation times 10,000 or something, then that becomes many more people than it actually would portend. So anyway, so keep a couple of decimal places in there is the answer. other questions on problem set 3? Emma.
Hi, yeah. For 4B, my question was, do we need to provide tables for those like 4BI, 4BI2, or just information on whether the relationship observed is like positive or negative and significant?
B or D?
B.
Let me
is
make
where-
sure I'm looking at this right.
Indeed asks for a full model. But then I was, or wait, no, in the, under B3 it asked for a table, but for B1 and 2, I was unsure.
Yeah, okay. So what that will look like is two different models side by side. And this is a really good kind of exercise to kind of practice, imagining this kind of thing. So I'll do this quick, I promise. I don't want to deter you from asking questions just because I take a long time to to explain answers. But let me, it's like too many things open here. Yeah, let me just give you a quick sense of what I'm talking about. So what we know is that you're trying to explain, I think, conflict onset, right? So DV is onset. And you're trying to explain that with a number of independent variables. And so what does that look like for our regression output? It means that we're going to have two models according to part 1 and 2, B1 and B2. So it's model 1 and model 2. And the variables, if I remember right, are refugees and regime and wealth and ethnic kin. And then you'll also have a constant term, right? And so you're going to have two different models. And what we know is that one model includes refugees and one doesn't, right? That's the point of that question, is to show you, well, what happens when we have a model just based on our controls? And so these are going to be like, beta coefficient and standard error, beta coefficient and standard error, et cetera, for each of these independent variables. But there won't be anything here because your first model doesn't include refugees in it. The second model, though, will have a beta coefficient and a standard error for refugees. And then it will also have a beta coefficient and standard error for the rest of them. And then, of course, you'll have your typical stuff like number of observations and the R squared. And then generally underneath that, right, there's like standard error in parentheses and then different p-value meanings, right? And so this is what your table will look like, and you want to have those two models side by side using your stout or stab command. Does that answer your question?
Yeah, definitely. Thanks.
Great. Now, really quickly, I thought you were talking at first about D, and I just want to say that I do think you should have a table in D. I don't know if I say make a table, but the best way to show those results for D is to do so in a table. Do I say make a table? Yeah, well-formatted table. And so, what will that look like? I mean, nobody asked this, but I'm gonna answer it anyway, because I have gotten this question plenty in the past. And so let's just very quickly say that can look a couple of different ways, but the main things that we want in our, when we get marginal effects using our margins command after doing a logistic regression. The main things we're interested in that final table, and if we need to discuss, again, interpreting the marginal effects table, we can. We talked about it last week, so you can refresh your memory there. But we want the predicted probability, right? That's important. And then we also want the standard error. Just like we want, in a regression model, the beta coefficient and the standard error as our main effects. And so what I would suggest is, building a table directly around those two things, right? Where you have, 4 different scenarios. So it would be like scenario 1, scenario 2, scenario 3, scenario 4. And then you give us the percentage for the predicted probability for each of these. And you give us the standard error for each one. It's really sloppy, but you get the idea. And so that's your table, really, right? I mean, it's just those things. Now, if you wanted to spell out what these specific scenarios are, you could. I mean, you could essentially take this out and then do like, something a little bit bigger up here. Wow. Gosh, you guys, this is the sloppiest, but right, you could do something a little bit bigger up here, and you could actually specify that this is like, this is like refugees equals the mean, wealth equals the mean, ethnic kin equals 0, or whatever they are. I don't remember these off the top of my head, and then polity equals 0. And then you could specify over here that, okay, that's the same, except in this one, it's no refugees, wealth is mean, right? Ethnic kin is 0, polity equals 0, or whatever the configuration of variables is. So you could spell it out in either way. The point is, make it good, and presentable. Okay, any other questions on problem set 3? Okay, well, if anything else, comes to mind, there will be time later if you want to jump in with a couple of additional questions on the problem set. What I'd like to do now is shift gears and go to the Michael Ross reading. So please open up that reading, and I'm going to ask questions and help narrate through that research design, just like we've done other empirical studies in the class, where we're going to focus on the elements of the research design and methods themselves, and try to see how this brings to light the notion of empirical richness. So let me find where my Michael Ross is. It's here. And I'll go ahead and share my screen too, because I know you all can kind of move it around to make it match, how you want to see my face or those of your peers versus the article itself. But this way we can all kind of be in the same place at the same time in the article. Okay, so what's the research question Ross is asking? Dylan.
What's the relationship between oil production and women in the workforce?
Okay, good. Before you ask the question in a way that assumes there is a relationship, right? Because maybe the answer to that is, well, there isn't, right? So before you do that, just pick the dependent variable, the outcome, right? And focus on that and asking what explains it. And that's really the route, I think, to take for the first version of the question. So go ahead and do that.
So is there a relationship between oil production and women in the workforce?
Okay, so you're asking kind of a yes or no as to whether there is a relationship between those things. Let's completely get rid of oil production for a minute. So you're right, and I'm just being very picky for a minute. Before we even presume a cause or suggest that we have a hypothesis about what the cause might be, focus just on women's labor force participation, right? And if that's our dependent variable, then what can we ask about it? I don't know the order by which we had you all raise your hands, but let me see. Janie.
What explains why women in the Middle East have made less progress in the labor force compared to other regions?
Okay, so that takes this kind of regional focus that tries to animate Ross's puzzle, right? I mean, he's trying to draw you in from the beginning to say, here's this puzzle that I have, and it is motivated by this observation that gender equality in the Middle East is worse than in other parts of the world. So what gives? What explains that? So that's true. What if we then try to generalize outside of this kind of exceptional focus on the Middle East, acknowledging that his study later is really global in nature, and it's really not concentrated on the Middle East. Maybe a couple of components are, but much of it is cross-national in a global way. How can we translate your question into a more generalizable one? Marin?
I was just going to say, what explains the underrepresentation of women in the workforce?
Good, close, although I would take away, I mean, and by close, I mean close to what I'm have in my head, right? What I have in my head. But what that does is it makes underrepresentation, or by using the term underrepresentation, it focuses on a fixed thing, right? Underrepresentation is a fixed value. It's not a variable per se, right? And so, I mean, again, this is overly picky, but I would say, representation, because representation could be higher or lower or none or some or much. Whereas underrepresentation maybe could. It's like the extent to which there is underrepresentation. Yeah, I guess that works too. I guess just when I heard it in that question, I thought, well, underrepresentation is this kind of fixed value that means it excludes all possibilities of adequate representation, over-representation, right? It kind of fixes our gaze on this one particular set of values. Whereas if we ask what explains variation in women's representation in the workforce, then it has the full range and span of that variable, right? Full representation, some, adequate, none, a little, right? And everywhere in between. But yes, that's exactly what we're getting at. And Ross is really emphasizing women's labor force participation, right? So we can think about that, as Marin said, as representation in the workforce. Right? And this is where Dylan was centering on before. And then Dylan's question brings in the potential answer, right? The one that Ross is going to hypothesize, which he said was, oil production. And so if I were to kind of tee this up in a data analysis project, I would suggest two questions. Always one that just focuses on variation in the outcome before we suggest the potential answer in the question itself. That way, we're not assuming too much about the answer. The first question is, what explains variation in women's labor force participation, right? And then the follow-up question is, to what extent or how does oil production affect women's labor force participation or representation? You can then try to motivate that question by noticing, as Ross does and Janie pointed out, that gender equality, women's labor force participation in the Middle East is lower than elsewhere. And that gives a clear indication that there is variation that needs to be explained, right? There is variation that is puzzling, that requires explanation. Now, there's one piece we're not hitting on here, and I'm wondering if Patrice is after this.
Yeah, actually, that was going to be my question, I think, was just what about the other variable about political influence?
Okay, good. And so I'm going to start it from a really high level, and then we can bring it down to where you just suggested we define it, which is the correct way, right? And that would be gender equality. And so what Ross is after here is trying to explain variation in gender equality. And let's notice just a couple of things as we work through this article, okay? So I highlighted some stuff, and I can post for you my highlighted version of this article if you'd like. It's highlighted specifically for our purposes of class today. But these reflect all different things that you all have said so far. And what we notice from Ross here at the very beginning is he's doing what I want you to do in your data analysis project in terms of motivating your question and providing us a little bit of literature that helps to frame your question or frame your topic. Ross does it very succinctly here, and then later he goes on into a much fuller literature review where he talks about how oil production affects female labor force participation and other things, right? So this section here, he covers quite a bit of what we would consider a standard literature review, including in this section on the causes of female labor force participation and the effects in Korea in particular. But let's skip that for now and say that where I see you bringing literature in is much more in line with what Ross is doing here at the very beginning. He says, look, there are some people who think that the anomaly of gender inequality in the Middle East is due to Islamic traditions, right? In other words, an ideational explanation. And so, he's kind of like, some folks say that it's about, there's an ideational cause, which is religion, or Islam. And so some people have proposed that it's this, right? That this increases gender inequality. Or so I should put it as decreases equality. But as you see, Ross then very quickly takes exception to that, right? And he says, well, it's not really that. It actually has something more to do. It has something more to do with economics, right? So it's actually that, as he says here, right, in this section, economic development arguments say that growth promotes gender equality. So his argument is that economic, or the argument of others is that economic growth has a positive effect on gender equality. And Ross says, essentially, yeah, but, right? He's making a critique. And what is his critique? Of the gender equality, I'm sorry, of the economic growth arguments. Yeah, Patrice?
I think he makes a distinction between different kinds of economic growth, and he says that oil production, if it's through oil production, then it's not going to have that positive impact on gender equality.
Right. Not all economic growth is the same, and it doesn't all have the same kinds of outcomes, right? Or doesn't have the same effect on different kinds of outcomes. And so he's kind of planting his flag in the economic growth camp. You know, he's saying, yes, I'm coming at this from an economic growth perspective, but I'm challenging that traditional model that doesn't differentiate between different types of growth. Because my argument is that oil production and wealth that is generated from oil production is going to actually have a depressive, right, a negative effect on gender equality, and it's going to run through women's labor force participation. So it'll have a negative effect on women's labor force participation, and then a negative effect on gender equality through that mechanism or through that intervening variable. And so how cool is that, right? That this now gives him off the bat empirical richness. And we're going to identify a few other ways too, right? But hypothesis one is that oil production reduces women's labor force participation. And hypothesis two is that oil production reduces gender equality, right, as a function of its effect on women's labor force participation. Now, let's dive a little bit further into the study. So we get those as being the two main hypotheses. He talks through all of his causes. I don't need you to justify your theory to the same extent, right? I want you to provide a succinct argument as to why your hypothesis makes sense. And this is where you also might draw on, you know, a study or two just to give you a little bit of a theoretical foundation for your argument. Again, we don't need a big lit review, but just a little bit of something to help, you know, make your argument convincing and your hypothesis, you know, follow some sort of set of reasoning. So we get these two different hypotheses, right? A rise in the value of oil production will reduce female labor force participation, and a rise in the value of oil production will reduce female political influence. And so what that means is we have oil production as the independent variable, right? The independent variable. And we have gender equality and women's labor force participation as two different dependent variables, right? So this is dependent variable one, and this is dependent variable two, and they correspond to these two different hypotheses. Patrice?
Yeah, I just have a question about the hypothesis. So, you know, the two dependent variables, the way they're related, couldn't it be like, couldn't the first one be an independent variable for the second one? Like the way that they're influencing each other. So couldn't you have rewritten the second hypothesis to reflect that?
Yes, although what ends up happening in Ross's model later is that he's ultimately trying to assert that it's oil production that is the real cause, the first cause, you know, and that it does work its way through women's labor force participation to have its effect. But he also claims that it does have, no, I was going to say he claims it has an independent effect, but it doesn't. All roads lead through women's labor force participation. So if you look out in a few minutes, we'll see that one of the things he does in his later models that look at the relationship between oil production and women's labor force women's political influence, is he includes as another variable in that model women's labor force participation. And that's not the only way to go about, nor is it, in my view, the best way to go about examining the effect of oil production on women's political influence as a function or through the channel or mechanism of women's labor force participation. In fact, it doesn't really do that at all. It's simply controlling for women's labor force participation. There are other more, let's say, advanced methods through which you can see the effect of one variable on another as mediated or facilitated by an intervening variable. But it's not something that we'll cover in this class. But I think that's a very welcome critique of his models and his method, and whether that actually captures what he's asserting in hypothesis 2 or not. Good. So with that said, let's just take a quick look at his data and methods here. He says he does 2 different sets of estimations. One is going to use first differences, and the other one is going to employ pooled time series cross-sectional data for all states between 1960 and 2002. I'm sorry, that's all the first one. The other one is a purely cross-national model, right? So we have 2 different models. Model 1 is time series cross-sectional data, right? That is leveraging or using first differences. And you actually know what that is, even if it doesn't resonate. We'll come back and you'll see in a second that you do know what that is already. Model 2 is simply going to be cross-national data. Okay? Or the second set of models. So here's model 1 down below that is the first differences model. Can anybody tell us what first differences means and why this might represent that, where we've seen it before? Does this ring a bell to anybody? I'll give you a hint. You really want to look on the left-hand side of the equation. And we know that the left-hand side is the dependent variable side. Anybody? Margaret? Unmute. It's also on the right-hand side of the equation as well, but I figured it would be easiest on the left. Go ahead, Margaret.
Yeah, is that kind of what we did with predicted change, where it's the difference between the change of one beta value of X?
Close. So on the right-hand side, we are talking about the difference between, so it's not the same as predicted change, but we are looking at the difference between 2 different values of things and subtracting them from each other. But we're not subtracting the beta coefficients. So that's what's different. But that's a really great stab, and it takes us a step forward. John Gates?
Was this like the aid lagging thing from or no? Like
not quite lagging. Think about when we discussed forced migration. It does take into consideration time though. So John Gates, that's also helpful, right? It's kind of looking at the temporal dynamics within data when we have time series cross-sectional data. Do you remember forced migration with Moore and Shellman? And we talked about the difference between stocks and flows, between the amount of forced migrants in a country at a particular time versus the amount of change in the number of forced migrants from this particular time to the time period prior. That was a while ago, I get it. I'll just tell you very quickly, what Ross is doing here is he's saying, how do these particular variables change from one year to the next? Because years are the time periods, right? And so what he thinks is at play here is the difference between oil production in one year and the oil production in the prior year or the next year, right? But it's the year over year change. And that gives our data a certain kind of dynamism because it's not about the total amount of oil production. It's about the increase or decrease in oil production from one year to the next. Right? So that's on the right-hand side. On the left-hand side of the equation would be women's labor force participation. or women's political influence, which we'll come to in a minute. And again, how that changed from one year to the next. It's not the percentage of women who are in the workforce. It's the change in the percentage of women in the workforce from this year to the next year. And so think about how that gives our data a different kind of dynamism and our analysis a slightly different meaning, right? He's not trying to explain just the static level of women who participate in the labor force based on the static level of oil production. He's saying that oil production increase and decrease over time within a country is going to affect women's labor force participation in that country as well, year over year. And so that's what we call a first differences model. And all we're really doing there, right, is taking the, let's just say the dependent variable at time t, as you can see here, actually, at time t, the dependent variable for any given country I, that's what the lowercase I is, the dependent variable of women's labor force participation, let's say, for country I at time t, and we're subtracting from it that same value at time t minus 1. And that gives us year over year change. And so, let's just say it's, we'll do this all for the same country. 1991, 92, 93, 94, 95, 96. And let's say women's labor force participation was, 33%, then it was 37%, then it was 42%, then it was 35%, then it was 34%, then it was 34%, then it was 39%, I should say, right? So this would be just the stock measure, right, of Y, women's labor force participation, right? So what is it in a given year? Now, what happens if we take the flow measure, right, or what we would call the first differences measure? Then this would be nothing, this would be 4, this would be 5, this would be -7, this would be -1, this would be 0, and this would be 5. Because we essentially subtracted 33 from 37, then 37 from 42, then 42 from 35. And this gives us this kind of dynamic temporal change in a variable as opposed to this, right? Which, first of all, is just at a much higher set of values. And therefore, the change looks far less when our range is at a much higher scale, right? And it also doesn't represent both pluses and minuses year in and year out that our continuous variable does. That our first differences variable does. So that's a first differences model. And so the same thing would be for the independent variable of oil production, where you could put oil production as a dollar value each year. But perhaps more interesting, especially when we're talking about variables that don't tend to fluctuate a ton. Like think about the federal budget, for example, right? The US federal budget or the Defense Department budget, it doesn't fluctuate a whole lot, given that we're talking about, tens of billions, hundreds of billions of dollars. Right? If it goes up by 50 million or down by 90 million, that's not much of a difference when we're talking about a scale in the hundreds of billions. But if we really want to capture that change of pluses and minuses, then we put it on the scale of change, not on the scale of the entire value. And so that happens when we do a first differences, looking at the increases and decreases as the variable itself. Okay, that's more than I wanted to say about that, but notice that a whole set of models are based on the first differences. A whole set of other models, though, are the second set that just use cross-national data There's no time component at all. And it's just looking at the dependent variable as a function of the independent variables. And this is the typical regression model that you're used to. Okay, now notice here he does a good example, or represents what I kind of expect you to do in your data analysis project, just like the other articles we've read, of walking through his different measures, the sources of those measures, right? Collier and Hoffler, oil exports divided by GDP. So he's very clear about what his variables are and where they come from. Now, what you would do, though, is be even more explicit about your level of measurement by saying this is a continuous variable, that is an interval scale that ranges from this minimum to this maximum, right? So I want you to really narrate out the data that you have. Let's add another piece of empirical richness, right? First, Ross says there are two different dependent variables, and we already uncovered that a minute ago. So that's one additional form of empirical richness. He has two different hypotheses, and he has an independent variable for each of them. One is women's labor force participation. The other is women's political influence. He studies female labor force participation with this data, right, from the World Bank. The other dependent variable is women's political influence. And notice that while that is a separate dependent variable, it also is measured in two different ways. So if we come back to our basic diagram of Ross, he's splitting this. First of all, he takes gender equality, as Patrice said before, and he says, I really am specifying that in a political lens, right? In terms of women's political influence. So that's his concept. And he says, I'm actually going to measure that women's political influence. So let me go ahead and change that here. He says, I'm going to measure that not in one way, but in two ways. I'm going to measure it in terms of legislative seats as a percentage, and also in ministerial seats. In other words, cabinet positions as a percentage. So now he's operationalized the same variable, women's political influence, in two different ways. And not just for fun, but to capture two different aspects of women's political representation and influence. One in a very kind of the masses way that focuses on the legislature and the parliament, right? A much more kind of grounded understanding. And then another one, though, that really represents the extent to which women have reached kind of the upper echelons of decision-making authority, right, in a political system. Not just that you're some MP representing some constituency, but that you have a cabinet portfolio that the president or the prime minister has selected you for. And so these represent two different kind of tiers and two different understandings of women's political influence. So think about, that as a form of empirical richness. Operationalizing a variable in two different ways that give you two different kind of lenses into your hypothesis, right? Your relationship. All right, let me move us along a little bit faster just by looking at these tables here. So notice he has a whole section called robustness. Robustness is another way of saying either empirical richness or kind of checking myself, checking my results across a lot of different models and specifications to see if my results hold up, no matter how I adjust my my models. And so he's going to describe to you, in this section, how his models are doing different things. So let's just do this visually. In the first set of models, he's doing that time series cross-sectional analysis with the first differences. And again, this is where he's telling a story, and I want you to tell a story with your data and your analysis. He first says, let me just do the controls only. This is equivalent to Emma's question in problem set 2, where I have you do a model that doesn't have refugees and then a model that does have refugees. So this is Ross doing a model without oil, and then in model 2, a model with oil. And he's trying to show you that when he adds oil to the model, right, we get this kind of added benefit by seeing an increase in our R squared across countries, and an increase in our R squared within countries as well. Now, these R squareds are interpreted differently than how you know, because he's doing a different kind of regression, but let's not worry about that too much. The point is, his model has improved when he adds oil rents. What's happening in the third model? And we'll skip the fourth, but what's happening in the third one? What do you notice here? Just looking at this, let's look here. Model 3. John Gates.
He removed the observations for 2 countries, it looks like, right?
Yeah. Why might he do that?
Because they're outliers. I don't know.
Yeah, they're probably extreme cases with extreme values. Patrice?
I think he's trying to like make it harder to prove his point and show that even when he takes out the 2 cases that make it easiest to prove his point, it still supports his hypothesis.
Bingo. He takes out 2 countries that have very extreme values on oil production, right? Very extremely high values, and that also have very extremely low values on gender equality. And I believe these 2 are Saudi Arabia and Kuwait. I could be wrong, but in terms of this particular analysis, right? His descriptive statistics, and this is where descriptives come in, as well as his graphical representation of data, if he were to do like a scatter plot of these different countries and where they stand on these 2 variables, would suggest that those 2 countries could possibly be driving the entire result of oil rents' negative effect on women's labor force participation. And remember, our goal is generalizability. And so you don't want 2 cases out of 161 driving the entirety of your significant results. And so Patrice is right when she says these are 2 cases that make it easier for his results to be significant. And so he's going to take them out to actually make his hypothesis harder, you know, or his hypothesis test more difficult. To say, well, what happens when we take out these two countries and all of their observations that have high levels of oil wealth and low levels of gender equality? Do we still, across all of our other observations, have this same result? And you do. He loses some of his statistical significance, but we have, and a little bit in terms of the coefficient, right? It's not quite as strong, but there is still sufficient evidence to suggest that oil wealth reduces women's labor force participation. Okay. We're not going to worry about the last one because it's a more complex method that we're not going to learn. Now, what happens in table 2? Notice how our number of observations goes from 5,000 something to just 100 and something. So what just happened?
He changed the years.
Yeah, in fact, he took them out, right? And so now we're not doing the time series cross-sectional data. This is that second set of models he said he was going to do just with cross-national data. No time series component at all. So here he has 167 observations for 167 different countries. And he's wanting to see how they vary purely across countries, not across countries over time. He's going to then bring in some of the same control variables as before, as well as a couple of others, including whether the country is in the Middle East, whether the country is communist or has a communist history, as well as Islam. And he explains above why those might be relevant, right? Certainly we can infer why Islam comes in. It's because he's wanting to have his argument compete with that initial ideational Islam argument that he dismissed in the very beginning, right? So he's going to say, well, does Islam actually have any explanatory value? Let's give those people who say so a shot here. And so he's going to bring that in. Communism, of course, in terms of labor practices and kind of everybody's contributions to the labor, labor contributions to the state and to the system, right, might have higher women's labor force participation. So he's going to control for that, et cetera, et cetera. So in the first model, we have just the controls. I mean, watch the story here unfold across the columns. Just the controls. In the second, it's just the controls, and then what about that other explanation of Islam? And he's trying to show you that, see, it doesn't really have any effect. At least not one that we can be confident in. What about my explanation, says Ross, right, of oil rents? Oh, it is statistically significant in the direction he expected. And also increases his R squared. And then what if we put those two arguments side by side, toe to toe, right? The Islam explanation and the oil rents explanation. Even when controlling for Islam, oil rents still is statistically significant with a negative effect and an R squared of 43%. And so now here we have 4 different models, all explaining the same dependent variable, one with a control, another with an alternative explanation that he's trying to kind of compete with, another one that finally includes his, and then a last one that's the full model that includes them all. Another form of empirical richness, right? Just provide multiple different models of different specifications of your analysis. And then I think we'll pretty much end on the next 2 things, just to wrap this up. I didn't want this to go past 7, so we'll be off by just a couple minutes. I love this table because this table leverages descriptive statistics. So take a quick look at table 3. You can read about it down below if you'd like. So we've now moved on from women's labor force participation, and he's using descriptive statistics to help move us to his second dependent variable, right? Seats held by women in the national legislature across countries. What is he doing with these descriptive statistics, right? Why not do it like we've seen before, where it's like, here's the mean, here's the median, here's the standard deviation, here's the minimum, here's the maximum. What's he doing in this table? Patrice?
It looks like he's just showing that when you look, like you stack them up next to each other, oil rich and oil poor, the seats are going up. And for Islamic, it still goes up.
He's trying, yes, that's exactly right. He's trying to show you that even before doing a hypothesis test, right? A difference of means or an ANOVA or a crosstabs or a regression or anything else. There's no p-value here, right? There's no statistical significance. He's just trying to tell you that the average percentage of seats held by women in national legislatures is different under different conditions. And so really what he's doing here is giving you the mean of parliamentary seats held by women, his dependent variable, under different if conditions. Right? So first of all, for every single one of these, it's going to be if oil rich versus if oil poor. Right? So what's the mean of parliamentary seats held by women if oil rich, and then if oil poor? But what's also in those if conditions is if high income and oil rich, if high income and oil poor, if low income and oil rich, if low income and oil poor, if Middle East and oil rich, if Middle East and oil poor, if Islam and right, et cetera, et cetera. All of this is to give us a sense of the data first, but also to give us a kind of suggestion before a hypothesis test that generally speaking, not across the board, but generally speaking, oil-rich countries have fewer parliamentary seats held by women than oil-poor countries. Which is his main second hypothesis, right? That where you have oil wealth, you have less women's political influence. And so let's compare across all of these different, let's say, country statuses or country characteristics, the oil rich ones versus the oil poor ones to see if we can, observe something like that. Now, again, that's not the case in all scenarios. Sometimes there's not much of a difference at all. In Islamic, right, it's kind of the alternative. Oh no, in Islamic, it's the way that he would expect. So it's either like, yes, this kind of confirms my thinking, or it doesn't suggest there's a relationship between them. So then, to conclude, in tables 4 and 5 below, we have the same kind of setup from above, but now with different dependent variables, as well as some other controls and that kind of thing. But notice across all of these different models, right, he's adding different specifications. So the first one is parliamentary seats held by women. The second one is ministerial seats held by women, right? So that second operationalization of women's influence. And in this one, it's, let's just look at income in the Middle East, then let's add in that other explanation of Islam, then let's do my explanation of oil rents, then let's do both of those together. Then, and this is to Patrice's question before, let's add in female labor force participation and see if there is an independent effect of oil rents when controlling for female labor force participation. And so, yeah, again, as I said before, this is a way to go about doing that. I don't think it's the best or most methodologically sound way to do it, but it's valid nonetheless. And notice what we observe, right? That as women's labor force participation increases, women's representation in parliament also increases. So he's extracting out that effect, right? The fact that as women's labor force goes up, participation goes up, so does women's representation in the parliament. And even when we remove that relationship or control for it, not remove it, but control for that relationship, we still see this relationship between oil rents and women's representation in the parliament as a negative one, as he expected. Then he brings in some other things like the polity scores, and different forms of representation. Okay, and then the same thing for the ministerial positions. So before I close this, I mean, that's really all I wanted to say here. We saw a number of different ways that you can bring empirical richness in, to the point that Ross ended up without too much effort, but a lot of thinking for sure. 1, 2, 3, 4, 5, 6, 7, 8, 16, and 5 is 21 different models, as well as a very thoughtful use of descriptive statistics across his dependent variable, or of his dependent variable across different scenarios and characteristics. I just wanted to give you this to kind of tell you to take heart. It's not too hard to figure out some ways to add to your basic descriptive, bivariate, and multivariate analysis in an interesting way. While at the same time reminding you that you're not supposed to be Michael Ross and have 21 different models, you know, and all of these different forms of empirical richness. I'm asking you for like, you know, a little bit, okay? A little bit. All right. Are there any questions about that or thoughts? Okay. So let me take a quick look at the syllabus. While I'm doing that, will you just queue up Stata very quickly? I don't think we're well, we'll see. Just go ahead and queue up Stata really quickly. Okay. Yes. All right. Is everybody, does everybody have Stata open? All right. So here's, I'll narrate for just a minute while you finish getting it up and running. Here is my thought. Nobody is going to be jumping immediately in over the next week to doing their final multivariate models for their data analysis project. Is that a fair assumption? Right? That you'll probably be doing some data collection and gathering, which, by the way, that is a high priority right now. You have to have, by next week, you have to have your data. Okay? And I'm just saying that because I hate, when I feel bad, it's not hate in a bad sense. It's that I hate the feeling of knowing that, you know, it's very close to the end of the semester, let's say 2 weeks or 3 weeks from now, and people are just coming to the realization that they can't find data that matches their project intentions, and now they're scrambling. So find your data by next Tuesday, or at least be able to come and visit me in office hours next Monday or this upcoming Thursday to say, I've scoured everywhere and I can't find data for my project. How can I adjust? But let's kind of know the status of your data and hopefully have the data you truly need to do your project. At least have located it, even if you haven't merged it all together, if you have multiple data sets, at least have identified the data sources and made sure that you have access to that data. You can download it, you can bring it into Stata, right? Know that by next week if you can. But with that said, again, my assumption is that nobody over the course of the next week will be kind of like bringing their final project into some sort of you know, completion, or be crafting your final models. And so what that means is some of the stuff I was planning on doing if we had time today, which falls under what I would call more on modeling, which has to do with things like fixed effects, transformations of variables. So we could test hypotheses that are maybe curvilinear in nature. For example, we've talked before about like a U-shaped curve, right? Where a hypothesis expects for the relationship not to be linear, but it's also not a dichotomous outcome for using a logistic regression. It's a linear model, but where you think that, for example, you might have at low levels and high levels of X, right? When X is very low and very high, Y might be very low. but at middle levels of X, Y might be high. So you get this kind of inverted U, or maybe the opposite, right? We can incorporate those kinds of hypotheses or deal with them with things like polynomial terms and other things. I can teach you how to log transform variables, which lends itself to different kind of interesting forms of interpretation of your coefficients. So I was going to enter into that a little bit today, just kind of at the, just the front end of my intentions. But I think we can go ahead and just call it and move that to next week. So that way we can end class early this evening. I know I've kept you a couple minutes over sometimes, so we'll just call class early. I asked you to open up Stata though for two very important commands. And these commands will help you as you work on your projects. And that it will also give you a little bit of practice installing packages into Stata, okay? And so does anybody remember how we install a package if we know that it's in the Stata repository of packages? Anyone? Kevin? Oh, you're sorry.
SSC.
I said Kevin because you're in the top left, and I thought you raised your hand, but you just happen to be up there. Who said what? Nick, go ahead.
SSC install.
SS.
Yes, good. SSC install. Okay.
Yeah.
Very good. And then we're going to install the package motivate. All right, and hit enter. Did it install for you all? All right, use the command. Use it again. Use it again. Okay, so as you work on your final project, if you're feeling a bit sluggish, go ahead and motivate. Okay. One other one. SSC install. Now, hopefully I spell this the way they spell it off the first bat here. Dad jokes. These are my favorite. Oh no. Let's try dad joke. Aha, dad joke, singular. And use it. All right. So I just wanted to give you two forms of motivation for as you go on finishing problem set 3 and working on your final data analysis project. If you have any questions, of course, you can take them to the forum or meet me in office hours, and I'm happy to discuss. Are there any final questions, comments, or snide remarks before we go? Patrice.
So can I put this in my final project?
Absolutely.
Great.
Of course, it's germane to your project. All right, very good. Take care, everybody. See you next Tuesday. I'll send you, of course, a message in the meantime. Adios.
Thank you.